Welcome to a lesson with Dr. Powell. Let's talk about why this cover-up method for partial fraction decomposition works with an example. We'll do it in two different ways. Let's do x plus 1, x minus 1, and let's just have a 1 there, that's fine. I mean, we could have anything here. We could have 1 plus x or something like that. But for simplicity in this explanation, we'll just keep it a 1. So we know that this fraction right here, we can decompose it as a over x plus 1 plus b over x minus 1 is equal to 1 over x plus 1 times x minus 1. Now, if we were to multiply this whole equation by this denominator, x plus 1, x minus 1, on this side, you'd have cancellation. So you just get a 1. Over here, the x minus 1 would cancel out, but you'd be left with an x plus 1. The x plus 1 would cancel out over here. You'd be left with an x minus 1. So you'd have this equation, this plus this is 1. Now, if you were to plug in 1 into this whole thing, what would happen? Well, this would go away. This would be 0. So add x equals 1. This thing, notice what would happen. Then you could even think of just dividing that x plus 1 over here before you plug in. So b will be equal to this at x equals 1. So it's going to like crossing this out and plugging in 1 into the rest. That's why it works. It's just a simple way of doing it, of getting right to it instead of just writing this out, because essentially you'll be doing the same thing either way. And likewise for the other guy. So if we were to plug, so that tells us what b is over x minus 1, but to find out what a is over x plus 1, think of the negative 1 would make that bottom 0 right there. So that would be like crossing this out, but then plugging in negative 1 into the rest over here. Negative 1 into the rest, you get 1 over, so you'd get negative 1 over 2, negative 1 over 2, and b would be 1/2. So you'd end up getting negative 1/2 over x plus 1 plus 1/2 over x minus 1. Okay, so this would be b, and this would be a. Thanks for watching.